So we have a transformation is an operation that moves or maps a figure from an original position to a new position. Transformations that we will consider are translations, reflections, and stretches. We're going to look at the translations today. So a translation is a transformation that slides each point of a figure the same distance in the same direction. So what we're going to look at today is vertical translations, up or down, and horizontal translations, right or left. So what we're going to do is we're going to take any type of function, and we're going to move it right or left or up or down. Maybe both. Okay? Last year when you did these, you did them only with quadratics. So it was just a parabola. You moved it right or left, you moved it up or down, and you stretched it vertically. That's all we really did with quadratics. Okay? This year, I can give you any function ever, and you have to be able to transform it. So we go from quadratics to any function in the world. Okay? So, in general, you can have it written in this form. Y minus k equals f of x minus h. Now that f just means that it is a function. That f just means you cannot type it in your calculator and look at it. So the moment there is an f, it's the transformations that happen to the function f. So what does that mean? Well, what I could do is I could technically, you don't have to write this, you can pay attention. I could give you a function that looks like that, and I could label this f of x. It doesn't have an equation at all, does it? I can't even come up with an equation to give to that. Now there's quadratic equations, there's radical graphs, there's all those types of graphs that can actually have equation that covers it, right? This one I would just say this is f of x, okay? Then I would give you the transformed form by putting something with an h and something with a k, like a 7 here or a 6 here. And the f just gives you, hey, these are the instructions, another way to give you instructions to move that. So this is kind of like if you looked at a treasure map, and the treasure map had instructions of which way you had to move yourself. That's what this is. These are just instructions of how to move f of x. So what could I do? Don't do this. I could put a g here. Then that would mean, okay, that's not moving this one because this one's f. That would be moving this one because I'm labeling that one g of x. So that would be the instructions of the g graph. So that's what that little f is in there for. That little f says, hey, I have to do this to the f, the graph that's f. If I put a g in there, it's, hey, I have to do these instructions to the graph that's g. Okay? What does it mean when you have that f in there? It means you can't type it in your calculator. Well, you can, it's not right. So don't. Okay. There are two forms that we can do. We can do the form where we have y minus k equals f of x minus h. I will never do this form. I always get it into y equals. So if it's in this form, I would actually add the k over and get it into this form. And that's the form I always use. Because if you use both forms, then you have to remember, oh, if it's in this form, I do this, and oh, if it's in this form, I do this. I always just make it into y equals and do the same things every single time. Okay? Now, going back to grade 11. In grade 11, you had the quadratic formula. You had a quadratic formula. Not the quadratic formula. You had a formula of a quadratic. Often it had a p and a q. Why they do p and q in grade 11 and then grade 12 the textbook switches to h and k? I have no idea, but it does. So, you were taught that, hey, there's actually this minus sign in there, right? So you were taught that if the equation was y equals 3x minus 6 squared plus 7, you were taught to actually, that this is x, this is minus, that p is actually just positive 6, right? You were taught that. Because the formula is x minus whatever the heck p is. So p, in this case, is actually positive 6, because it's x minus p, and q is 7. You were taught that last year. So you were taught that p moves right or left, and that q moves up or down. So if p is positive, this is 6 to the right. And if q is positive, that's 7 up. Okay? Now, it looks like it's x minus 6, so it looks like it should move 6 to the left. But remember, it has that hidden minus sign in it, so p is actually the 6, not the minus sign. So it's 6 to the right. So that's why you always do the opposite of h and the same as k. Because look, this one has a minus sign in it, this one doesn't. So I could give you instead y equals 3x plus 6 plus 7. I could have gave that last year. Well, that's actually the same as writing y equals 3, x minus a minus 6 squared plus 7, isn't it? Because a minus becomes a plus. And then if I match up the equation, y equals a x minus p squared plus q, my p is actually minus 6. So that's why it's the opposite of that always. Not just memorization, but that is why. Because there's that minus sign in there. Okay? So, if h is greater than 0, you are actually moving h units to the right. H being this, not the factor bracket, right? So how could I look at that? I could say y equals f x minus 3 plus 7. That means I have a horizontal translation 3 right. And then this is a vertical translation 7 up. This one's always the opposite. This one's always the same. Okay? Always opposite, always same. Now you can't just write it however you feel your heart sings. You have to write it in an actual, like it cannot change. I have to say for this one, I have to say horizontal translation 3 right. And a vertical translation 7 up. So you always have to write it in that form. You could write horizontal translation right 3, and that would be okay flipping those two. But you have to start off with horizontal translation. So many people on the test go 3 right, 7 up. You're not getting the marks. You have to say it's a horizontal translation 3 right. It's a vertical translation 7 up. You need to know your words. So once again, if someone doesn't put in the time and learn those words, your test mark's going to suck. Right? Because you need to write it the way it is. Okay. The next thing I want to go over is mapping. We'll go over replacement later, but for right now I want to go over mapping. Mapping you use whenever you have a graph or a coordinate and you're moving it. So we're going to use mapping whenever we have a graph or a coordinate to move. If I'm moving a graph or I'm moving a coordinate, I'm going to use mapping. Now why when I'm moving a graph? Well, a graph is just a whole bunch of coordinates, right? So if I'm moving a coordinate, if I'm moving a point, I'm using mapping. If I'm moving a graph, a whole bunch of points, I'm using mapping. So that will be drilled into your head by the end of the unit. Whenever you move a point, you use mapping. Okay? Mapping and words are the same. So I always do this. Yeah. I do a heart, and I put mapping and words in it. Because they are in love. They're the same thing. Same way to represent the same thing. Because mapping is literally just moving a coordinate. Just moving a coordinate is mapping. Okay? So, if I have an XY coordinate, which is what I start with, an original. This means the original XY coordinate. And for mapping, you have to do an arrow, because that means it becomes. So my original point becomes what point? That's what mapping is. Well, what are the words of what I said? I said up there that I'm going to move 3 right. So my X has to move 3 to the right. What do I have to do to this X to move it 3 to the right? Add 3. And then I need to be a vertical translation 7 up. So I need to take the Y value and move it 7 up. How do I do that? Add 7. That's it. That's mapping. Words tells you how to do it. It's like a direction. Mapping shows you how to move a point, a coordinate. They're the same thing, just a different way of representing the exact same thing. Okay? All right. We'll deal with replacement notation later. So we're going to look at this one. The graph of y equals f of x is transformed to that. The very first thing I'm going to do is rearrange it so it's in y equals. So I'm going to add the tool. And it goes to the back. And I get y equals f x minus 3 plus 2. Now, what are my words? Well, my words are horizontal translation 3 what? 3, always the opposite. So if it's x minus 3, it's actually 3 to the right. Because it's, remember, it's x minus, and then this is actually the answer, this number sitting here. Because it's x minus always, and then the answer. And then a vertical translation, what? To where? To up. So when I go to do my mapping, this makes sense. I have my x, y, my original coordinate. My x is going to add 3 because I moved 3 right, and my y is going to add 2. Does that make sense? So whenever I do words, I'm going to do mapping immediately. Even if it asks me for mapping, I'm going to show my words. If it asks me for words, I'm going to show my mapping. Why am I going to do that? So that it becomes part of your being, that they're the same thing. Because what happens is the test comes and you're like, oh crap, do I keep it? Do I switch it? Do I keep it? Do I switch it? Do I keep it as a negative? Does it go to a positive? Does it switch? Does it keep? Like, you're like, no, I won't. You will. People flip them all the time. Okay? So we're going to practice it over and over and over so that you can do it in your sleep. You don't question yourself. So here, I have, so if the point 4, 6 is on the graph of f of x, that means this is the original point. The moment I'm moving a coordinate, I'm using mapping. I don't even think twice. I'm not like, should I use mapping? I'm using mapping. It's what I will do. So I immediately go down and I make my mapping. xy is going to become x plus 3, comma y plus 2. And I know in this lesson it seems really stupid to write mapping because you can add 3 and add 2 very easily, right? It wouldn't be super stressful to you. However, we're going to have vertical translations, horizontal translations, reflections in the x, reflections in the y, vertical stretches, and horizontal stretches. Then it gets overwhelming. So when it's easy, we want to keep practicing this. So when we add them all together, it's not overwhelming. Okay? So it says, so if the point 4, 6, original point, was on the graph of y equals f of x, then the point would become 7, 8. Let's show that. So the original point is always goes into the first bracket. So 4, 6 would become, well, now I'm going to go 4 plus 3, comma 6 plus 2. And it's going to become 7, 8. So it shows I'm right. And honestly, if you can get your mapping down, it takes all the guesswork out of the question. It makes the question like ridiculously easy. Not a lot of brain matter needed after you have the mapping. Okay? When you're done that, we're going to flip over. Okay, these ones I want you to describe how the graphs of the following functions relate to y equals f of x. So y equals f of x is the original, no transformations. How do they describe them? So I want vertical and horizontal translation written and what they're going to do. And I want mapping. Mapping is an extra. So I want the words and I want mapping. So we'll do the first one together. So the first one is in y equals already, so that's good. This is in the bracket, and it's with the x. So if it's with the x, it's a horizontal translation. So it's a horizontal translation. 3, what? 3 right. And then I told you we're doing mapping too, because it means the same thing. So my original point is xy. It's going to become what? I need to move 3 to the right. I'm going to take the x and I'm going to add 3. Do I do anything to the y? The y stays y. Because look, nothing happened back here. Right? You're going to try B, C, and D. So for B, the only difference we have, I'm going to start recording. Okay. For B, is that with my X? No, if it was with my X, it'd be in the bracket, right? So some people at first, because it's so new, will forget that. Make sure your phones are away. So we're going to have a vertical translation for what? And then we have our mapping. X, Y becomes, my X is just in a bracket by itself, right? So nothing happens to my X. I need to move 4 up. How do I move Y 4 up? I add 4. So mapping is literally just taking that coordinate and moving it, right? How do I do that? How do I move a Y 4 up? Well, I add 4 to it. How do I move a Y 4 down? I would subtract 4 from it. This one, I have a vertical translation. Eight down. And then my x, y, my x is still in a bracket by itself, so x did nothing. And to move 8 down, I have to take that y of my coordinate and move it 8 down, so I subtract 8. This one is a horizontal translation. And it doesn't matter if you do vertical or horizontal first. Horizontal translation, 7 left. Has to be opposite. And a vertical translation, 4 up. And my mapping will be x, y becomes x. I need to move 7 left. So I take that coordinate and I subtract 7 to move 7 left. And I think my y needs to move 4 up. I add 4. Okay. This is that replacement notation that I said we were going to get to. So what happens to the graph of y equals f of x? The following changes are made. So I replace the x with x plus 2. So what does that mean? I go into this equation, this y equals f of x equation, and I physically grab the x with my hand, and I toss it behind my head. I just throw it away, and I'm going to replace it with x plus 2. So I fill in x plus 2 in it. So I take the x, I toss it out, I take the x plus 2, and I physically hand it in there. So what happened? This is a horizontal translation, 2 to the what? 2 to the left. And my mapping would be x, y becomes?
X minus 2.
And just y. Okay? You try this one. Now this is the catchy one. So we have y equals f of x. I'm replacing the y with y minus 8. So I'm physically grabbing this y, and I'm throwing it behind my head, and I'm replacing that y with y minus 8. So I'm not putting the minus 8 at the back, right? I'm doing replacement. I'm taking that y, tossing it, and replacing it. So you give me what the transformations are and mapping quickly. Bless you. What's the first thing I should do? Move. Yeah, move the 8 over. So you get y by itself. I knew what you were saying. So we get y equals f of x plus 8. So it's a vertical translation, 8 up. You should have that. So you have vertical translation, 8 up. And then your mapping would be x, y. If I need to move a coordinate 8 up, I'm taking the y of the coordinate and adding 8. Right? That's how you would move it up. Like you can visualize it. You can say, hey, I have an x, y. I need to move this 8 up. Well, if I do x plus 8, that's actually this way, right? That's not up. So it should make sense. The people who understand this unit do really well. The people who try and memorize this unit do very badly. Because you can just memorize something wrong, and you get every question wrong. And every answer in the multiple choice has the oopsie. Has if you are adding it to the y instead of the x. Or you're subtracting it instead of adding it. Okay, so you need to understand it. People who understand this do way better. So the x stays the same because nothing happened to it, and the y I added. Okay, the next one, it says the point. I'm moving a point. If I'm moving a point, I use what? Mapping. It should be like point, mapping, graph, mapping. It should be immediate answer. Okay? So the point, now I have to read, does this point lie on the transformed graph or does this point lie on the original? Because that makes a big difference. So the point 2, negative 3 lies on the graph of y equals f of x. So this is an original. So that's my xy coordinate, right? My original. State the coordinates of the image. The image just means the transformed, the moved coordinate. The coordinate you took and you actually did what it says you have to do, right? Okay. Of the image of this point under the following transformation. So the first thing I'm going to do here is subtract 8. And so I'm going to get y equals f of x minus 8. Now I'm moving a coordinate, so I'm going to do mapping. My xy becomes what? Anyone know? The x stays the same, and the y minus 8. Now that I have mapping, no brain cells needed. Literally plug that into the original and then plug it into here, right? No brain cells. This is the hard part, the part before this. So 2, negative 3 becomes 2, comma, negative 3 minus 8, which becomes 2 and negative 11. Now, if you're someone who's in your head is like, Lep, this is ridiculously stupid. If I just take negative 3 and I subtract 8, I have the point. That's true, because this is an easy lesson. Remember I told you we're going to do 3 different lessons, adding more, and then slam them together? And if you don't know how to do this on the basic part, when I slam them together, it's really scary. I don't want it to be scary. Okay? You're going to do B, moving that same point. When you're done B, I want you to try example 4. Coming up with the new equation. I'm going to do attendance. So you're finishing example 3 and doing example 4. Yeah. Tomorrow. I have one person to write it, and she's writing it in period 3 tomorrow. Make sure you're trying example 4 as well. That one you should get 9-2. This one says write the equation of the image, so the new equation, after each of the following transformations. So we are going to go 5 to the left. So we're going to get y equals f x plus 5. 5 to the left has to be opposite, right? And then a vertical translation 3 up. So y equals f, don't touch the x because it's not horizontal. And it's 3 up, so I add 3. Okay? To times. Now, what if I do with variables? Horizontal translation, m units right. So I'm going to get y equals f x minus m, so that it goes to the right. And the vertical translation, p down, minus. How'd you do on that one? Good? Like I said, I know these are easy, and that's good. I hope they are, because we're going to keep adding more to it. Okay? Tomorrow we do reflections, the next day we do stretches, then we put them all together, then we do inverses. Fast unit. Fast unit. They're all fast. Oh my God. All right. This one says, in each case, the graph of y equals f of x is shown. Sketch the following transformations for each case. I am moving a graph. A graph is just a fancy way of saying, here's a buttload of, buttload. I just said it twice and it's not recorded. Yeah, awesome. Here's a whole bunch, that's what I should have said, of points. We're going to move them. When we're moving points, we use, don't all answer at once, mapping, right? This is just more than 1 point. We're still doing the same thing. And you're like, it's 2 to the right left. I'll just go. Yeah, on this, I hope you do that. The next one, we're going to use mapping. When it's 2 to the right, I hope you just go, hey, 2 to the right. Hey, 2 to the right. You know what's scary? Moving this one to the right, then this one, then another one, and you randomly move them and then you connect them all wrong. That's scary. So we're going to do sequential order. So I started at this one and moved it 2 to the right. Started this one, moved it 2 to the right. Then I'm going to connect them because they were connected, right? Then I'm going to move this one up here 2 to the right, which is here. And then what am I going to do? Connect it. There's so many of you guys who will get your coordinates correct and then you connect them wrong. Okay? And you're like, how would I do this one wrong? This one's easy, remember, but they get harder. So we're in practice. This one we're going to move 2 to the right, and then I'm going to connect them. So I'm going to move 2 to the right, and then I'm going to connect them. So if it's a basic 2 to the right, do I expect you to show mapping? No. The next one, however, I want you to do mapping because we're just going to practice it, because when I add 4 more different types of transformations onto this, it makes it much more advanced than this one. So we're moving coordinates, we use mapping. So here I'm going to subtract the 2 first. So what's my mapping? Well, my x, y will become x, and it's plus 3, so I'm going to subtract 3 because I'm moving 3 to the right. And then I'm moving 2 down, so I need to go y minus 2. Remember mapping, if you can remember that mapping and words are the exact same thing, just a different way of representing the exact same thing, you will do fine. Now, why would they give a different way of representing the exact same thing? Well, because if I ask for a description, you're going to give me words. But if I ask you to move a coordinate, mapping is a heck of a lot easier, right? So that's why you use 2 things that mean the same thing, because they're used for different situations. They're better in different situations, okay? So I'm going to move this point. It's 1, 2, 3, 4, 5, 6, 7, -7, and 2. And it's going to become -7 minus 3 and 2 minus 2. So I'm going to get -10 and 0. It's here. Now we can double check it. So you move 3 left, 1, 2, 3, and 2 down. Boom. Right? Like I said, I'm not doing mapping right now because it's harder. I'm doing mapping for practice. Then I pick the next point. It's at 1, 2, 3, 4, -5 and 2. And I'm going to fill it in. -5 minus 3, 2 minus 2. So my new point's at -8 and 0. And you have to put the arrow in mapping because it means like this becomes this. The arrow actually is a math term you need to have, the symbol. So we have -8 and 0, which is here. I put 2 coordinates and I connect them, right? And I go to my next one. 1, 2, 3, -3 and 1, 2, 3, 4, -3 and -4. It becomes -3 minus 3, -4 minus 2. And so I get -6, -6. And I connect them. I go to my next one. It's at 2 and 1, 2, 3, 4, 5, 6. 2 and 6. And it's going to be at 2 minus 3, comma 6 minus 2. which is -1 and 4. And then I connect them. And then my last one, 4 and -4. 4 minus 3, comma, -4 minus 2 gets me 1 and -6. Now, why is mapping so important? If this is a written response question on your test, and you just draw a graph without any work for me, I can't even, how can I give you marks, full marks? Worst case, you draw that entire graph and you get one coordinate wrong. If you show me, if this graph is out of 3, or out of 2, let's say, if you show me all the work and I see, oh, you made an algebraic mistake there, you'll lose 0.5, right? It's the same thing on the diplomas, when they mark diplomas. It would give us a rubric, and if you had 1 point off, that just meant you were near perfection. You bumped back 1. So if it was out of 3, you got a 2.5, because you showed your work as to why you got them, right? So we knew you knew what you were doing. You just made a silly algebraic mistake. All right. This one gives you mapping and gives you a point. It says, state the coordinates of the image under the transformations described by this. Well, what I want is the new point, and I want you to actually give me the description. So now I'm giving you mapping, you have to give me the description. Now in grade 11, often you're given a graph and you have to give the description. That was it. Or you're given the description and you have to give the equation. That's it. In grade 12, I can give you mapping and ask for the point, ask for the new equation, ask for the description. So you have to be able to move from any of these, mapping or otherwise, and get all the other forms. So I want you to give me the new coordinate, but I also want you to give me the description. The description is horizontal translation this, vertical translation this. Okay? So try out example 6. The words people mess up here. Now, I took the coordinate x and I subtracted 7. So which way did I move? Left. People want to flip them all the time. You're literally just, I took an x, subtracted 7. Oh, my hand physically moved 7 to the left, right? So horizontal translation, 7 left. And a vertical translation, I was at y, I added 4. Moved 4 up. So remember mapping, words, same thing. Just a different way of representing the exact same thing. That's why they're in a heart. Mapping and words. This one, I would do -3, 5. Becomes -3 minus 6, 5 plus 1. Gets me -9 and 6. So I'm at x, I subtract 6. I'm moving 6 to the left. And the vertical translation went up. Example 7 is one of the ones that's done the worst. Because remember, when you do these, you have to say, here's what the equation was, here's what the new equation is, right? So your original equation could already have a vertical stretch on it. So if it shows you the same vertical stretch in the next one, nothing happened. It's just the same graph. So when you're comparing two equations, you have to compare what moved, what changed, what's different. Okay? So for example 7, it says, describe how the graph of the second function compares to the graph of the first. Well, this one is y equals x to the 4. This one is y equals x to the 4. Oh, and then I have this plus 3 at the back. That's the only different thing. Is it with the x? Nope. So it's a vertical translation, what? 3 up. And if I did mapping, it would be xy becomes x comma y plus 3, because that's the way I can move it 3 up. Okay? B. I have tons of people adding random crap that doesn't exist on here. Because remember, you're just telling me the transformations that occurred, right? This is y equals 6x minus 3. The 6 and the x and the minus 3 were all there, right? So now I have y equals 6x minus 3. Oh, the only thing that's different is this, minus 1. So what happened? That's it. Horizontal translation 1 right. That's it. All the rest was there before. Don't go stating that it moved 3 down. It didn't move 3 down. It was 3 down. It's still 3 down. It moved nowhere down. Right? So it's a horizontal translation. One right. We're going to look at D. I can give you any equation I want under the sun, even ones you don't even know what they look like yet. Ones that we're maybe going to talk about later. Graphs of rationals. Right? Graphs of radicals. So if we look at D, this is actually a radical graph in a rational function, which is like the very last thing that we do. It doesn't matter if you know what it looks like or not. What matters is if it's with the x, it affects the x. If it's at the back, it affects the y, right? So here's my 1, my square root x. Here's my 1. Here's my square root x. Ah, with the x is a plus 1. So I moved 1 to the left horizontally, right? It's nothing different. It's not crazy. It's still with the x. So it's the horizontal translation. One left. And then I have a plus 3 at the back. So it's a vertical translation. Three down. When you're done, we're going to flip over. So this one says, write the equation of the image of. So here, it says, after a horizontal translation, 3 units right. Horizontal translation, 3 units right. So that's going to go in with my x, right? In order to be in with my x, though, I need to put my x in brackets, and the squared has to still be outside, right? Now I want to move 3 right. How can I make an equation that would represent 3 right? X plus 3? X minus 3. Because remember, when we take it from the equation out, it should match. Sometimes people are better with, okay, drawing out the equation and then going, okay, that's 3 to the right. Oh, yes, it's good. Or like you put a plus 3 and you're like, no, that's 3. Ah, crap, it's supposed to be a minus. So sometimes you're better off just trying it out and then working your way backwards. Because people are usually good from going equation to words. Now this one, it has a vertical translation 2 up. If it was a horizontal translation, I would have y equals 10 and then x minus 2 or something, right? But it's not horizontal, so it doesn't join there. If I did, it would be up in the exponent. And it's 2 up, so I just go plus 2 at the back. So don't overthink these. If it's horizontal, it goes with the x. If it's not, it just goes to the back. Okay? We're down to example 9. Now this one says, the function represented by the thick line is a transformation of the function represented by the thin line. So which one's the original? The thin line, and then the thick is the transform. So we just have to read to make sure we don't mess it up. So we're starting on this thin one, and we're going to here. The best way to compare them is something that's actually the same. If you do arrow to arrow, does it actually say for sure that this arrow ended when this one did? No, because arrows don't end. Arrows can keep going. The only thing I can compare here is the vertices, and these are an absolute value graph. Okay, so that's what I can compare. I'm going from this blue one to this green one. So how do I get there? 1, 2, 3, 4 down. And then 1, 2 right. And then I can represent it as an equation. The original equation is labeled here, y equals f of x. That's the original. It's going to become y equals f of x. I need it to be 2 right. So I'm going to go minus 2, and then 4 down, minus 4. And I'm done. Okay? Then we're going to flip over. We have one last example. A little challenger question. Okay. This is bringing back a little bit of grade 10 as well. This one says y equals square root x is a radical function. It's just an equation they gave us, right? We can find any, if we could put in any x, we can get any y. We can get any coordinate off here. Like if I put in a 4, I would get y equals 2, right? So the equation, the point would be 4, 2. If I put in a 16 for x, I would get a 4, so it'd be 16, 4. I can get any points. Whenever I'm giving you an equation, you can input an x and get out a y. Input an x, get out a y. You were taught that in grade 10. Make a t-table. Put in an x, get out a y. Okay? So like an example, if I went y equals square root of 4, then I put a 4 in for x, then y would equal 2, and I get a coordinate, right? You can get any coordinate off of there by inputting some x, getting out a y, right? And keep that in mind. That's the grade 10 info we need for this question. Now it says, what is the vertical translation that would be applied to this so that you get this new point? What is the vertical translation? So what's the only thing that's been affected, my x or my y? My y. My y is the only one that's changed, technically, right? So if I went to represent this coordinate, it would be 16 something. Now it says, what vertical translation would be applied to the original so that this is a transformed one? So 16 something becomes 16.7 is essentially what we're saying. Right? Does that make sense? Now, this is the original. Is there any way I can get the y from the original if I have the x? Nope. My equation is y equals root x. I have an x. Just put 16 in for x, get your y. Right? That's it. Now, if they had transformed the x and the y, we could not do this. I don't even know how you do it. It would be an awful question. They'd have to give you more information. You can only do this because they're only affecting the y, or they only affect the x. If they affected both, we can't use this method. So we can fill it into here and get our y. Y equals square root x is our original equation, and I know x was 16. So I go y equals square root 16, and I get y equals 4. So my original point was 16 and 4. I could find that. What did I do? I went from 16.4 to 16.7. What did I do? Vertical translation. 3 units up. I was at 16.4. I went to 16.7. Just 3 up. That's it. Right? This one, what horizontal translation would be applied to this so that this would be the translated point? So my new point is 17.8. What the heck was my original point? It says horizontal translation. So what's the only thing that changed? The x. So my y still is an 8, right? That didn't move. If I'm given a y, can I find an x on my original? Yeah. So my original is y equals root x, but y happens to be 8. So 8 equals root x. How can I get x by itself when it's square rooted? Square it. So x was actually 64. So we're going to think about it. I'm at 64 and 8. So move over 64 and up 8, right? And now I'm at 17.8. Which way am I moving? 64.8, 17.8. Which way? I'm moving left. How many? How many? What's 64 minus 17? What's 17 to get me to 64? 17.3 to get me to 20. 47. Yeah. So it's going to be 47 left, which I should write horizontal. Horizontal translation. This is your homework. It looks worse than it really is, because you can easily state translations like this very fast. Last week you had one homework with two numbers. Not last week, the week before. So I think you can pull your weight this week. I believe in you. Honestly, transformation, the people who do their homework are the ones who do well in this unit, and the people who don't, it's dicey. Because you have to practice and practice and practice until it gets into your long term. They say you have to do the same thing 10 times before it hits your long term. If you keep this in your short term, you will mix up subtracting and adding when you're not supposed to. You will. So start working. You guys, you have like 20 minutes. There's a good chance you could even come close to finishing this. This is not a hard assignment. It looks long, but it's really quick. So off your phones, start working.